Hello everyone. In this video, we are going to discuss Theorem 6.2, which is also called as Converse of Basic Proportionality Theorem from the Chapter 6 Triangles, Class 10 Max. You see, according to this Theorem 6.2, if a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle. See, this theorem 6.2, it is actually the converse of basic proportionality theorem, which was theorem 6.1. We discussed that in our previous video. According to the theorem of basic proportionality, that is basic proportionality theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio, that is basic proportionality theorem. The converse of that basic proportionality theorem, that is theorem 6.2. According to this theorem, if a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle. So let us see the proof of this theorem. For that, here I am considering a triangle ABC. Consider a line DE such that it divides these two sides AB and AC in the same ratio. That is, we are considering a line DE such that AD by DB is equal to AE divided by EC. And I am taking this as equation number 1. See, if it is so, as per the theorem, this line DE, that should be parallel to the third side, which is BC of this triangle. That is what we want to prove. That is, we want to prove that this line DE is parallel to this side BC of the triangle. So to prove this, let us assume that this line DE, which is this green colored one, it is not parallel to this side BC. Okay, we are assuming that this line DE, this green colored one, it is not parallel to this side BC of the triangle. And let us consider another line DE dash. Okay, we are considering another line DE dash, which is parallel to BC. Okay, we are assuming that this line DE, it is not parallel to BC. We actually want to prove that DE is parallel to BC. But we are assuming that DE is not parallel to BC. And we are considering another line DE dash, which is parallel to BC. Okay, we are considering another line DE dash. And we are assuming that this line DE dash is parallel to BC. See, if DE dash is parallel to BC, then as per the basic proportionality theorem, which was theorem 6.1, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. That is, if DE dash is parallel to BC, from basic proportionality theorem, we can write this AD divided by DB is equal to AE dash divided by E dash C. And I am taking this as equation number 2. Okay. Now, when you compare equation number 1 and equation number 2, you see the left hand sides of both the equations are the same, AD by DB, AD by DB. So we can equate their right hand sides, AE by EC, which will be equal to AE dash by E dash C. So we can write AE by EC is equal to AE dash divided by E dash C. Now what I am going to do is, I am going to add the number 1 to both the sides of this equation. So when we add, see, this is AE by EC. I am adding 1 to this. This is equal to AE dash by E dash C, and I am adding 1 to this. Now, Let us do the cross multiplication. So 1 is like 1 by 1. AE into 1 AE plus 1 into EC divided by EC into 1 EC. This is equal to, this is like 1 by 1. AE dash plus E dash C divided by E dash C. Okay, cross multiplication. Now you see, what is this AE plus EC? See, AE plus EC, that is actually equal to this side AC. So we can write it as AC divided by EC is equal to AE dash plus E dash C. AE dash plus E dash C. That also gives you this side AC. So AC divided by E dash C. Okay, so this AC and this AC can be cancelled. So this can be written as 1 by EC is equal to 1 by E dash C. I am taking the reciprocal on both the sides. So this becomes EC by 1, which is EC. E dash C by 1, which is E dash C. So we are getting this result, EC is equal to E dash C. Okay, now you see, this is possible. That is EC, that will be equal to E dash C. This is possible only if E dash and E coincide. Okay, E dash C and EC will be equal only if E dash and E, these two coincide. Since DE dash is parallel to BC, E dash and E coincide. So DE, that also must be parallel to BC. Because we have assumed that DE dash is parallel to BC. We got this result EC is equal to E dash C. This is possible only if E dash and E coincide. That is, if they are at the same place. Okay, so if DE dash is parallel to BC, then DE will be automatically parallel to BC. This is the proof of this theorem. Okay, so according to theorem 6.2, if a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle. I hope it is clear to you. Thank you.